help companies into the retail and e-commerce sectors to optimize their business by building or integrating AI solutions. So let's go into our presentation. So AI has the power to transform industry, to drive innovations, and to help to solve lots of challenges, one of the biggest challenges of mankind. The increasing adoption in AI has impact, not only reshaping business, but also in our day-to-day life. But however, this surge has raised some concerns, some ethical challenge, some privacy concerns that has to be taken when we deal with building AI solutions. And building AI solutions has its own complexity. We handle vast amount of data, we handle randomness, we handle the expectation of the hype that AI has created. So we have to get good sense of how we build AI solutions. And what we're going to do today is to review some case where building was not so great, or the AI that was built was not adequate or appropriate. We're going to review some cases. Some cases are known, we probably not there. Some are more of our experience. And from that, we're going to extract some recommendation or best practice. Also, what we don't want to do is introduce specific technicalities that surround AI, some concepts like bias, drift, or MLOps, just to shed some lights on this in order to, let's say, decrease the gap of communication between the technical, non-technical, and leadership. And in a sense, improve better decision process when we build AI solutions. So let's start with a first controversial question, right? Is AI just about ChatGPT? I think OpenAI has 100 million of users in 2 months. It has really put AI in the mainstream, and I think it deserves that title for good or worse. But yeah, if we look at the frequency of the search of the AI in Google, we see that there is a burst into the frequency around end of 2022, which totally correlates with the rise of ChatGPT. So ChatGPT really put in the mainstream the AI. Even if AI was there way years ago, but at least in the mainstream, this is how it is. If we have a reference on common and very important term, now ChatGPT and AI has passed, at least on the search, the number of queries, the number of searches that people do on Google. Very impressive. It's not at least as sex, unfortunately, but that's another story. So regarding AI, it's just about ChatGPT. I think now we are a little bit more in the eclipse effect. ChatGPT is so big, so huge, so much impact, so much potential that we probably don't see what lots of AI things that has been doing. And actually, it's also for this. It's not about ChatGPT in this type of model. So these large language models that are instructed to create things. There is a lot of other models. So I don't know how familiar you are with all these things, but Anthropic, Mistral, Gemini from Google, Meta from Llama from Meta, a lot of large language model applications based on large language model now are popping up, trying to trace their path behind OpenAI or looking for more niche market. So these all are generative AI. This is what we heard now every day in our technological one, and not so technological, generative AI. So it's just not about creating text or handling with text. We also have multimodal A lot of applications now are creating audio, creating video, creating image. So we really are, let's say, impacted by all these models that create new things and has a huge potential in all our things. But I think this eclipse effect, we tend to forget that there is a lot of things under the umbrella of data-driven AI. These are systems that works based on data. We learn from the data, both generative AI and the other things which are more traditional machine learning ML. And so many things have been built on based on machine learning model, and it's still the most part of the investment going on is still 70% of the investment in data-driven AI solutions are still in these traditional ML solutions. And we have classification, clustering, forecasting for retails. Most of these solutions based on AI are traditional ML, forecasting demands to handle stocks, classification of the user to segment and to understand the behavior of the users, anomaly detection in trying to have a fraud detection system. We understand when a transaction is different, weird, and we flag that as a possible fraud transaction. A lot of things is done on traditional ML, and just a point here. So generative AI is so impactful, but let's also think about the things that have worked and still worked as traditional ML when we build AI solutions. So this is data-driven AI. Actually, yes, machine learning, actually all the paradigms that we use to build that system power the generative AI, all this supervised and unsupervised learning is really the background of learning that is using generative AI. So we have data-driven AI, that kind of solutions. This solution is also in this ontology of AI. We are still in the narrow AI, which means that they are systems that are teach to do something well. And this is what we say now, teach to do things in one concept. And it's still hard to make these things learn in other modalities when it has been taught to learn in one thing. On the contrary, we have the aspirational AGI, artificial general intelligence, which reflects the intelligence and the ability to learn in one domain and others and reproduce things in other domains. So really trying to get the learning in different modalities. We're still not there. We're still in the narrow AI. There is discussion about if generative AI is a first step to AGI, but also that's another discussion for future. Well, what we're going to review are use case more in the data-driven AI, and especially machine learning and some generative AI. So let's start with reviewing some cases, and I'll let the floor to.
Thank you, Antoine. So we can agree now that we've been hit by this AI wave already. Now the question is, we can now surf this AI wave. The problem comes whenever this AI wave is sweeping us away, right? And now we're going to see an example here of a use case which this problem actually happened. So that is the first case study. It's from personal experience in this case. So I was hired some time ago by a company, an e-commerce company. They had no recommender system in place. And my task was to continue a project that they've been developing for some time, which was to create a recommender system, which was using cutting-edge technology. And they, high management, they wanted a system which all the bells and whistles. But just bear in mind that there was no recommender system in place. So it took us 9 months to develop this system. And after 9 months of development, whenever we wanted to put the system in production, that was not possible because the day before the release, we got noticed that the company was discontinuing activities. So we are all laid off, right? That was unfortunate. So what happened there? One of the problems was that we put too much emphasis on the technology, not really the problem we wanted to solve. And that was a mistake. So we should have first the problem, and then use the tools of artificial intelligence in that case to solve this problem. Also, as you can see, that the development cycle was very, very long, which meant that we were missing opportunities on the way. During those 9 months plus X months that they were developing this system, there was no recognized system in place. So maybe we've been missing things there in production. So what can we learn from this failure? As I was saying, use AI as a tool for a need to solve a problem, not just because AI is cool, right? Find the right problem and solve it. If it requires AI, we use AI, but the goal is always to solve a problem. Also, don't get dazzled by this very nice technology. Use the technology that is appropriate for your use case. And also, if the domain allows you, start small, fail fast, so you put things in production fast, analyze what the results are, and then iterate quickly. I understand that there might be some domains which that's a bit trickier, like health, security, but in some other domains like e-commerce, just try things with a small amount of people, small amount of users, and get some feedback and iterate fast. And now I give
data. So data quality. Data is key in this data-driven AI solutions, obviously. Let's review the case of Amazon. Probably this one you know that in 2014, Amazon developed a tool to help hiring. It was an automatic screening resume. So they had lots of resume for the job, and the first step was to select or discard the resume based on certain characteristics. So they deploy that, they push into production, and then they analyze it, and they realize that system favor male over female, independently on the qualifications. So consequence was a potential legal issue, right, with this hiring process. I think they were forced to abandon the tool. They didn't manage to solve it in a way, and it became like a standard of the buyer's problem into the ML solution. And what was the issue? So this ML was built on the dataset that was consisting primarily of male resume, because it was historically more male was applying for technical jobs, but the dataset was really reflecting the stereotypes of our society. But they built a model based on that, so the model really reflects the characteristics of the datasets. So and they see that AI learn pattern to really downgrade whatever was referred to the review. So the dataset was biased and lead to unfair solution. And this is where we come to our first two words or two technicalities that always come up and pop up in AI: bias and unfair. So before trying to conclusion and maybe solutions, let's try to have a deeper review on these two terms. And bias. So bias in data refers when there is imbalance or skewed representation of your words, and this leads to our model. To create inaccurate predictions. There is different type of bias, as the one that we've seen in Amazon. It's more than historical bias. It reproduces stereotypes of our societies. Other bias are in the common text, in general in the internet. Our texture, the way we write, the way we all what is published textually in the internet is usually gender bias. We used to associate he to a doctor and she to a nurse. This is set up by lots of research, And an example of generative AI is reproducing this bias that we see in the internet. There is a very nice experimentation done by Bloomberg. They use some generative AI application which creates from a text, which creates an image. So what's done, they use the prompt like, give me a person, or create me an image of a person who is CEO of blah blah blah. And this, they've done it a number of times. It was thousands of times, and they study how the image was, and they study specifically the tone of the skin. And what they've seen is using CEO as a word. The personage, the image created was more likely to be white skin than black skin, and this is done with using I think a known generative AI application on this image that has been trained on all the datasets that we have in internet. And if we ask for, give me a person who is a fast food worker, well, it was much more probable that there was a more dark skin image than light skin. So really, generative AI is really reflecting what we have in the dataset. That's why it's very important to have an understanding of the quality of the dataset in different sense, and bias is one of the main things that we have to take in mind. Well, this was about historical bias. This is how we behave, how our society is. Now there is more, let's say, bias introduced by our processing. When we build AI, we have a choice to make. We have to decide what kind of data set we want to. And there is this sampling bias where we may act in a way that we don't use all the data set that we should use because it's not representative of what will be our data in production, and we use a small one. For example, if we train on retail a machine learning model to forecast or to classify, let's say, to classify users as they behave on the retail platform, if we only use, let's say, user from the mobile part of the platform, and we apply that for all users, mobile and webs, the system will probably don't work. We will probably don't work for the type of data set, the type of user we don't train on, because they have obviously different behavior. So we really have to think when we build, what is our representation, what is our data that we want to have in production, and build this AI solution with a training set that represent all this casuistic. Yes, and the point is, we've seen, the model will be as good as your data is, at least. And we are a data-driven AI, so this model learns from the pattern of the data, learns from the correlation of the data, and that's where this title comes. We used to say garbage in, garbage out. If you have very bad data quality, you probably you can put a lot of money on creating a model. You will have a model that will barely hit the performance that you want. So first, take the quality of your data inside. And fairness is the other part of this problem. The bias, the characteristics of imbalance and secure representation of data, and fairness is the characteristics of what you want for your model. So when the bias leads to inaccuracy in your model, and this inaccuracy impacts groups in a disproportionate way, will lead to unfair outcome regarding the groups. And fairness is the quality of the model. We want to assure that AI decisions do not favor or in favor one group over another. And this is especially important in some area like employment, law, or access to healthcare. There is different way to validate if we have fairness and also to mitigate in our model. It's first to use metrics. I'll just put here 2 metrics to understand what we're talking about. So there is demographic parity. This is a very simple one. We want equal probability in each group. For the case of the Amazon resume screening, what would be? If we have, let's say, four male applying to a job and we have 50% male that is passing the first step with our model, we should have 50% of female passing our model. That's a very simple one, not the best one because we don't take into consideration the underlying qualification. So we used to, this is not the one really they used to handle into the models. What we go is more about equal opportunity. And the definition is we want equal probability of positive outcome across groups, but for qualified individuals. Let's say that we have this 4 male, but just really 2 well qualified. And if we have 50% of this one that pass to the second step, we also want 50% of the female passing to the second step, independently of how many they work. It's based on the qualification. So there is different way to validate the fairness of our model, different way to mitigate our training to take into consideration not only the accuracy but the fairness. And that's also important to understand that when we're building solutions, especially in different areas as we see. But this leads me to the next step, which is ethical regulations. So there are ethical regulations that impose some rules and something that you have to do when you build AI solutions according this different way to segment the groups. The GDPR, you probably all know this is one that's it's quite older. It's more based on the rights of the users according his data, but it's already enforced also in this case, the fairness and non-biased data on age, gender, and race. Also, there is now the EU AI that enforce this compliance, and it really puts some restrictions on the provider of the system, especially in the high-risk system. They have a classification of what is a high-risk system, and they are usually a system that works in employment, law, and healthcare. And this system really have an enforcement on not to be biased in age, gender, disability. There is now, I don't remember, but there is 3 more groups that we have to be taken care of. Two other examples: an EU Employment Equality Directive, because it's probably discrimination based on protected characteristics like age and gender, and also an EU Insurance Policy Directive. So since I think 2012, the price cannot be biased, or it has to be fair. It cannot be biased over male and female. So there should not have been some difference taking into consideration gender on price of insurance. So lots of things to take into consideration: quality, regulation, because it imposes quality, but you also have to really think about this kind of thing when you create. So it leads to the lessons that learned on. Invest in quality of your data. Implement AI governance. No? This is a set of policies that guide responsible development of your solution. do regular audits because data change. We're going to see the type drift. So do the audits very regularly, monitoring, and yeah, promote more transparency in your system, how you build accuracy, how you solve the and lead to more fairness algorithm, and know your regulations. That's some of the lessons of that case. I think we're ready to go on the third case.
Thanks. So we like to automate things using AI, right? We want to automate as many things as possible because that way we are more efficient. But there are certain cases that this is not really a good option. And that brings me to the case study number 3, which was the case where Boeing, the aircraft company, they built the 737 MAX, which was bigger than the usual 737. And the problem with this aircraft was that the engines were bigger than the 737. They were placed slightly in different position of the plane. And what happened was that this aircraft was not that stable, and it tended to tip upwards, right? So the nose of the plane used to go a bit upwards. In order to stabilize the plane and put the solution here, they decided to put a system called MCAS, right? And this system, what was doing was that whenever the system identified that the plane was going upwards, it would push automatically the nose of the plane down in order to stabilize. That seems like a good idea, but it turned out not to be, because there were 2 crashes in 2018 and 2019 that were related to this system, and actually a lot of people died in this crash, so very fatal outcome. What happened there? Well, according to the sources we read, the system relied on a single sensor, which was faulty, so it was sending wrong information to the part that had to do to make the decision. Also, this system could not be deactivated easily, at least. It was hard to deactivate. And moreover, pilots were not really, they didn't receive any specific training for the situation. So that was very, these 3 things were very, very bad for that led to this outcome that we just saw. What can we learn from this those tragic accidents? Well, always try to keep humans in control of important decisions. So it's nice to automate, but whenever there are important decisions, put humans in control, at least that they review the decision that the system made. Also, in certain situations, consider whether you want to augment the capabilities of humans by using AI, or you really want to replace the human by AI. So that will depend on your use case, but consider this case. Also, be transparent towards the user. So if the user is dealing with an AI system, just make sure that the user is aware of that. Don't try to hide that there's an AI behind. So if we have this chat bot popping up, it's nice to know that we are talking with an AI system or with a real person. And also, importantly, in AI, but not only, also in other parts of software development, implement some redundancy systems, some rollback systems, such that whenever shit hits the fan, you can get back to your previous state and make the system work as you expect. We go now to the next topic, which is about not testing your solution in an appropriate way. That is another example from Microsoft. Microsoft put a chatbot on Twitter called Type in 2016. And the idea was that this chatbot should interact with users and learn on the way. So in real time, the system was supposed to learn from users. What happened was that internet trolls found out about this bot and then decided to start interaction in an appropriate way with the chatbot. So they were teaching the chatbot offensive language, inappropriate language, racism, conspiracy theories, and so on. So in less than 16 hours, Microsoft had to remove Ty from Twitter and make an apology because it became as nasty as this face here. So what was the problem there? One thing was that maybe they didn't test the system enough with real world scenarios. Maybe they didn't think that the users would interact in that way with a chatbot. So they missed this test that they had to do. Also, they left AI in an uncontrolled environment without putting any safeguards or any content moderation, and that is also very tricky and very dangerous. So what we learned from this case is that it's always good to conduct thorough validation using real-world data sets and also include edge cases. No matter how random they might seem, they might become mainstream, so you want to test with edge cases. Also, put continuous monitoring and retraining of systems. So you want continuous monitoring because the sooner that you find out that there's something going wrong, you want to act as fast as possible, and also retraining. So those systems, if they learn over time, things might change, the environment might change, so you want the system to be up to date all the time. And whenever you put the system in the wild, an AI system in the wild, put moderation systems, safeguards, because don't underestimate the creativity of users. They will always try to jailbreak your system, so try to be, before that happens, try to do as much as you can to avoid this situation. And now I go to the third use case, which is in those situations where the generative AI gets on drugs. That happens sometimes. Let's see what I mean by that. It's a well-known feature of generative AI, like ChatGPT, for instance, that in some situations they hallucinate, which means that there are some facts that they make up those facts. So they are not real, but they write in a way that they seem real. And we believe that this is correct, but they might be completely made up. And that was what happened to this lawyer in New York last year, where he used ChatGPT to create the brief for a lawsuit. So he asked ChatGPT, and then he went to court. And the problem was that ChatGPT generated some false case citations and some legal precedents that they never existed. Right? So whenever the judge found out, of course they weren't happy with that, and now the lawyer is facing some financial penalties and some formal reprimand. According to his defense, he said that actually he didn't know that GenAI was creating hallucinations. He thought that it was like searching on Google, but in a newer way. So he was not aware of those hallucinations. But what was a problem for him is that he didn't verify what he found. So that was a failure from his side, that he should have verified the sources before going to the court and trust blindly the AI system. Oops, sorry, I just pressed the wrong button. So a lesson, always verify the veracity of the AI-generated facts. As a user, you need to do that. As a developer as well, whenever you develop a system, if you can provide the sources of facts that the GenAI is telling you, it's always better, because that builds trust on the system. Also, don't try to substitute the professional judgment by AI. As I said before, use it to augment or as a tool to help, but not as a substitute of those important matters. And implement guardrails. So there are some guardrails which are specifically tailored towards identifying hallucinations. They don't find all of them, of course, but the more you can find, so the better the system is going to be. And now I give the word to Antoine again.
So, case study, production, what can be wrong when we push to production? Actually, lots of things. So it's a personal experience. We were working in a second-hand car marketplace, so we were building tools to to make automatic inspections possible. So our company buys some car, inspect the car, and then we sell it to others. So this inspection tool has to be quick and automatized. So we work in oh, sorry, completely changing the, sorry, this is another case, coming back, reverse. Oh, okay, this is it's also a case, a personal case, when we work in this company, second-hand car marketplace. We were working in the lead acquisition funnel. So it's the same things. The company has to get the cars from sellers that want to sell the car, and then we buy it. So the more cars we go to the funnel, the more we can sell it to others. So we had to improve the funnel. And in the funnel, some users drop out of the funnel. There's a system that classifies this type of users and say, this one has dropped out of the funnel, but it could be good to call them because he has a probability, a likelihood to be interesting into the system. So these are the systems that we build, a lead scoring. So we put a score to the leads that went out of the funnel to be called into the system. So there are different features, behaviors, the type of cars, and so on. And we deploy our leads, we work on our lead scoring model. We deployed on production, and the outcome was that nothing happened as we expect. So there was too few leads were prioritized, and which could lead to downgrade of the metrics. But in the training, the metrics was good, and we were expecting quite a huge increase compared to the baseline system on the leads that could be called to the and put in the funnel. So frustration, consequence, too few people remain in the funnel, and the drop in conversion metrics. The issue, what was the issue? Actually, what we've come up is that the data processing that we used on training was completely different from the production. Because in production we had to go from another system, and the data changed, and the way the process the data was different. We were interpreting null value as different things, and all this come up that the type of data that was pushed to the model was quite different, the distribution from the one that we trained. And that's one of the errors that come up when we push to production. That we say the training and selling skew. This abrupt difference between the data set of your training and the data set of production. And that's before going to conclusions. Let's go and have quite a review on what's going on here and try to put some lights on this drift effect. So here with data is key. So with software engineering, when we push to production, there is three pillars. No? There is the code, there is the infrastructure and the integration, and you have to take care that this is going well when you push to production. In AI engineering, you have these three pillars also, but you have also the data. And you can't control everything on the data. You have to have good practice in order to to be sure that the data you use in your development is the same as the production. And this is where comes the drift. Data is key, but data can drift also. So the drift is the change in the statistical property of the data. When you see something in training and it's different from the production. And it affects the performance of the model because the model was trained on a type of data that it's not anymore. That's a kind of drift. The drift can be abrupt, like our examples. We pushed the production and it was totally different because sound processing was different. Or it could be gradual, and it's more an organic drift because your behavior, your user change. Yeah, let's dig a little bit on the type of drift. So we have covariate drift, which is a change in the data distribution. Let's say pre-COVID in marketplace, electronics and clothes were the item most sold on the platform. And during COVID, this changed completely. We need more furniture to get our home nice, and the distribution changed completely, and furniture dominated the market. So if you had a model that works well with electronics, because you have lots of data on that, and okay for the furniture, when during COVID this model decreased its performance. So data can drift, and you have to take care of that. Another kind of drift is concept drift. And the concept is a change in input-output relationship. An example is in pre-COVID, the average likelihood of a phone being sold was in 30 days was about 60%. During COVID, this value dropped to 40%. This is the same iPhone, the same characteristics. So here the data have not changed, the same features. The thing is, the behavior of the user meant that the relationship between the data, the iPhone, and the likelihood of purchase has changed. This is another kind of drift, difference, and this also has to be taken into consideration when we build the model. So data is key, but data can drift. And solutions, they are applying what we say MLOps and model governance. So MLOps is a set of practice that simplify and automate the development of your model and the deployment. It has some good characteristics, so you can enforce traceability. You know what you've done to your model. You know it can enforce reproducibility. You can reproduce exactly the model, the artifacts that you've been doing in different experiments, and you can streamline the deployment. So from training to validation to deployment to monitoring, it can package this and push that to production. It's not just about the code, it's a whole system that you have to push to production. So MLOps practice, data monitoring tools, don't go blind into production, push before the necessary system to monitor and put alerts on that. Even if it's a small system, really, that should be the same priority than pushing your model. You have your monitoring in place. And build in some way adaptive models. Try to think about retraining pipeline. Try to think about the drift and how to scale depending on the chain distribution your models. So I think that's it for this concept of drift and how it's important. And as a lesson for this training service queue, well, think about that the feature engineering consistency. What you do in the data in training should be the same, exactly the same in production. Put in place monitoring and alerts and test your model with production data. One good thing about that case is, when I said that there was a drop in metrics, there was a drop in metrics in our simulated model. Because what we've done is we push to production, we push in shadow mode. That was the good thing that saved us. Shadow mode is mean that we push into production, but still the baseline model is working. We streamline the data to our model, but it doesn't have any impact. On this, we managed to detect the error before getting impacted into the business. That's another lessons from these cases. And I think the last cases is related to this different culture that we have in a company, in a technological company. And that's the case that I was starting to describe before. So we're still into this second-hand marketplace dedicated to car. So we build some tools to improve the auto inspection tools. And one of the tools was to classify image of a car. So the user, when he wants to sell his car, he has to do some 10 pictures of his car And there was a system that classified the image into different parts of the car, so that there is other models then that are triggering and some other stuff, some quality detection on the part. So we build the model. The model achieved an expected 90% accuracy because it was quite noisy image at image level. So from 10 images, we expect 9 was good and 1 has an error. However, the PO expected also 90% of accuracy, but like cars. It means that they wanted that in 10 cars, 9 cars has all of the image correct, and just 1 car could have 1 or more image not correct. So here it's a case of lost in translations. When we start the project, we didn't agree clearly on the metrics. And this leads to complete frustration in both teams, and we have to redefine part of the project. Yeah, the issue was a misunderstanding of the final success metrics. And the lessons here are we have to get clear alignment with the stakeholders on what has to be done, and specifically on what is the success metrics of your project. Let's try to focus on the business metrics, at least when you talk to the stakeholders. And have this clear, frequent communication. So quickly detect misalignments and correct this gap. Also, what I've seen that's important is this capacity to translate technical metrics to business. Sometimes when we go in too much detail in explaining the technicalities of how our model is behaving, there is a gap that happens, and it's not perceived correctly by stakeholders. So we have to, as a technical person building AI, we have to get that capacity to translate and communicate the technical metrics of data science or machine learning. Yeah, an appendix to that cases in our experience when we build into that marketplace into OLX or into Leitco, we had that a different culture. There is product, there is engineers, and there is the AI data science / ML part of the team. And these are different focus, different approach, different mindset. So product is more user-centric, AI is more hypothesis-driven. We have to check, validate this kind of hypothesis. Engineers more about robustness, clarity, make things done. And the approach also is different for the 3 groups. Product is more pragmatic, based on user feedback. The AI is more iterative experimentation. And engineering is more about linear incremental value by ending sprints. Mindset different also. Products more time to market when I'm going to have the features. It's good fit for this type of market. AI is more long term. We want to test the best model. And engineering about this dichotomy of technological depth and deliver in time the system. So this clash of culture, it's create conflicts, create misalignment in success metric, misalignment in time expectation, and also ownership and accountability. If only a data science wants to create a model, the best model, and then pass to the engineers, maybe we didn't think about the scalability issue of that model, and it cannot be deployed in the resource that it has to be. So this still silo, this clash of culture can create that conflicts and consequences. These deadlines, market opportunities, suboptimal AI solutions. So one of the recommendations is always about communication and collaborative. So try to build collaborative ownership and of AI project, and one of the key solutions is create shared KPIs. When KPIs are not shared between the different groups, it leads to misalignment. It leads to not focusing on the things that has to matter. Put KPIs, put shared KPIs between the different groups to make the project work. Favor continuous testing and feedback loops, and work on communications. Share stories, newsletters, demos, create cross team sessions. So AI can learn from software engineering practice, and software engineer can learn from this iterative process of AI. So that's has been working well in the different companies. And explain the way of work of AI. And this is where we go on the next slides. Way of working. So we probably, I don't know if many of you are familiar with this way of work of data science, which creates a data science life cycle. So we have business understanding, data preparation, modeling, evaluation. This is in an infinite loop. This is based on 3PM data science life cycle. And I think it's important when you build that and work with engineer or product, that these other groups know how you build that. It's important. What are the different steps, and understand the complexity of the project. So data science life cycle is a set of steps you take to deliver a project. Important to show and communicate. This is an infinite loop. I don't like how it's been set, because it's not really how it's being done into the company. Usually, in the company you have more a sequence approach, because you have to get a roadmap. You don't loop infinitely into this. You have to put some timeline and rough estimation. So what we like is more having this kind of loop, but inside a sequential roadmap. And we're going to explain that. In general, we first start with the feasibility assessment. So we talk with the stakeholders, we understand the business, what is the problem, how we could fix that, what would be the success metrics, and we have to understand based on data if it's possible. Sometimes we don't have data, it can't be possible, or it can't be achievable what stakeholders want. There is that first back and forth interaction with stakeholders to say, okay, do we have a green light, can we do that, or do we have to postpone? And this is our first assessment with the stakeholders. This business understanding, data understanding are one of the two steps of the data science life cycle that we've shown in an infinite loop. But we put it in this first step of this incremental roadmap. Then we have the proof of concept. And we differentiate proof of concept and MVP. Proof of concept is more trying to validate that this is feasible by creating some code. And this is where here you kind of loop. You have data preparation, you model, you evaluate. If it fits the performance that you wanted, go. If it doesn't fit, you iterate, because it's an iterative process. You may also go back to stakeholder and say, we have to change because this is not possible. Let's try to refine. And this is a loop. And when you come to a point where, okay, we have an agreement of this work gives the performance that we want, we go for, let's say, which is we can push to production. Here there is a deployment, because sometimes, even if this in this book, you need to test things in production, maybe in simulated. And what I put here also is, depending on the maturity of the team, building the pod sometimes is building an MVP, depending on how mature you are in your MLOps and development team. But usually what I've seen is you have a pod, you have a proof of concept, and then you go to MVP, which is different things that you have to take care. You have to deploy in a scalable issue, you work more with an ML engineer, and you have then, when it's done, you have to evaluate. This is where here monitoring has to be in place. You don't go blind in that. And then you evaluate and probably iterate. Another, in this roadmap, you pass to MVP in iteration 1, and another iteration. You may go to this proof of concept, going back into the in infinite loop, or you may go also to feasibility tests as well. So this is how we like to show how the way we work, and I think it's put some clear clear understanding for the Azure team for how we can build a product together. Another things I will quickly pass. So you expose your way of work, you communicate that to stakeholders, and then internally you have what is the best way to work with your team. There is different way. Usually what I've seen is it's more of a agile because it's an iterative process. You can do it with Kanban, Scrum. There is as Scrum as teams. So they all do their way. So I'm not going to put too much time in that, but I will put one reference, data-driven Scrum 4DS, which is an interesting thinking about how to adapt Scrum to data science. So keeping the best things of Scrum and say adapting the things that works best. So I put it as a reference. That's a good one. And with that, we finished to review the different cases, and we're just going to make a summary.
Thank you. Okay, so it's 10:05. We all need a bit of coffee and sugar boost. But before that, let us recap what we've seen. And then it's going to be time for questions, and then we can have our notes. So, first thing we've seen, have a clear objective in mind. Whenever you build an AI, have an objective, define the objective based on business needs. You want to solve a business problem. Use the AI as a tool, not as a means. So you want to solve the problem using AI, not the other way around. You don't want to use AI and then you find a problem. Set the success metrics before you start the project. What is your goal? Improving the conversion by X%? Make it clear. Second point, human always in the center. First human in the center is your end user, so have the end user in mind. That's so you want to solve a problem for your end user, have them in mind. Be transparent to the user. If the user is, again, dealing with an AI system, make it clear. And in certain situations, consider whether you should extend the human capability rather than replace the human altogether. Third point, collaborative approach. Agree on shared KPIs. So you have your KPIs. Make sure that everybody in the team, internal team, external teams, everybody is aligned to those KPIs, and they are all working towards achieving those KPIs. Promote agile and clear communication habit, as just Antoine explained lastly. And build your cross-functional teams. So you want your teams to, you want teams that can do different things. Don't make them work in silos and don't communicate. Fourth point is the ethical framework. Always be aware of the regulations, basically because they are imposed and you can get fined if you don't follow the regulations. So that's an important point. Remember in Europe, GDPR, the newly EU AI Act that entered into force, I think, last August, if I'm not mistaken. And then also use the FAT principles. Apply fairness, be fair, we'll make sure that your algorithms are fair. Accountability, make accountable the team who built the system, the people who build it, they are accountable for the outcome of those systems. And transparency. In that case, we mean transparency by the algorithm. If the algorithm is making a decision, try to be as transparent as possible on how this algorithm made that decision. If it's a black box and we don't know why the decision was made, that is a problem. And then going to the last ones, it's all about quality. We want quality in your data, so invest in a platform. So in order to make sure that your data is of good quality, having the platform in place that can help you validate this quality of the data, that's important to have. Implement data governance, so not everybody should access all the data. Some people should have different rights to access different parts of the data. And run periodic control. We've seen that there is this drift, and we want to regularly review that our data is as expected. Quality about the model as well. So know what are the limitations of your algorithms. We talked about the hallucinations, this limitation that they have. But other algorithms, they have other limitations. Make sure you know them and don't make assumptions on what they can do and what they cannot do. Validation before training, or before the beginning. So from the not before, sorry, I wasn't right. So from the very beginning, you want to start validating all the steps you do with your model, and not finding out that the model is not working as expected at the very end of the development. The sooner you find out, the sooner you can react. And then also mind the train serving skew. So make sure that the data you use for training is the same as the data you use in production, because otherwise you're solving the wrong problem. So when you move to production, the model is not going to perform because of the data. Product quality. Whenever you move to production, you want the product to have a certain quality. Therefore, make sure that you have redundancy and rollback systems. If something doesn't work as expected, have an easy way to get back to your previous state. Introduce moderation systems and guardrails in order to guide the users and the model not to go off track. And do this real-time monitoring and alerting. So the sooner you get, the sooner you know that something is going wrong, the sooner you can react and solve the issue. And finally, in order to have the quality on those three topics, ensure that you have a process which is also good quality. That means adapting MLOps platform or principles. For instance, you can have a platform that help you in building, deploying, and monitoring all together in an integrated way. Fail fast, iterate quick. Antoine talked about the shadow mode, that is putting the system in production, but not impacting the result or the user. It's just for you to analyze how the new system is working. You can perform canary releases in certain scenarios. Canary releases meaning that instead of putting the product for all your users, you just put the product for just a small amount of users and then find out how it's going. And then if it's going well, you can open the new feature to the rest of the users. And the last one is this continuous learning and adaptation, either by having an algorithm which is able to learn over time, or if that's not the case, you do the retraining over and over again with the new data every now and then. And with that, we conclude this talk. Here I leave just the links to all the materials that we've been using, a couple of slides for that. And now we open the time for questions. And if you want to visit what we do, just feel free to come to our website. Any doubts, we will be happy to discuss and answer some of the questions you might have. Thanks for your attention. So we open the question session now. Are there any questions? Yes?
So you mentioned about the cross-functional teams. Let's say in the sense of software engineers and data scientists. Would you prefer component teams or like feature teams, and what would be the pros and cons for the programmers?
You want to take this one and run, or do you take the position?
So we work in different environments. Actually, we work first we were in we had a team with only data science, and then we had another team which was ML engineering, and another team which was data engineering. Data engineering is always in this transversal capability, transversal. So it was always creating capability that then you can use. So we always work in where data engineering was more apart as a transversal. The thing is, how do you combine ML engineering and data science? And this is where we work in different combination. What we've seen in the case where there is just data science and then ML engineering, we looked that there was some bottleneck issue. there's sometimes the model built by the data science has to be rebuilt from scratch by the ML engineering. It leads to more time into the development, and we saw some problem into communication. So there was always back and forth to understand exactly what the model is doing, how it has to be done. So we prefer the other way where we were working more in a T-shaped kind of team, where the whole team can actually do from development to deployment. So it's more about combining cross-functional with data science and machine learning, which are able to push to production this model. It also depends on the maturity of the MLOps practice in your company. If you can rely also on a structure that can boost the productivity of the data science, meaning that you already have a framework that is very easy to deploy, very easy to monitor, then you can let even the data scientists with some or no experience in deployments do the jobs. If you don't have that, you probably have to get this team more cross-functionalities. And I prefer to work in that configuration.
Yeah, I'm aware that you might be biased because you're consultants, so unbiased your answer if you can. But where does it make sense for a company, big, small, also like your answer is going to be probably depend. So if you give a little bit of like rationale, get into the question. Where does it make sense to build Gen AI solutions internally, and when does it make sense for a company to just hire externals and like make or buy? And in which cases do you think would be wise to do one versus the other, the competences and
Okay, I think it's always better to hire external, and not anybody but us. That's first time. Having said that, yeah, I guess that it depends on the company and also the structure, as you already forecasted the answer. But maybe to start with, if you don't have the infrastructure or you don't have this knowledge in your company, it's good to hire some consultancy or some external people that can come in and start doing maybe some small project in which you can see the value of that. That would also help the company to understand the value and see that AI is not magic, it's just a tool that it's very useful, but that way the people in the company can understand the benefits and lose a bit, be not as afraid as sometimes they are, because we are a bit afraid that AI will take our job. So, that way it helps, and then you build momentum with that. And after that, depending on the reaction and the impact it has, then maybe it would start to make sense to get people inside that can do that. I would go for this approach.
What we've seen also, because that's true that now there's so many tools that lower the bar to enter into generative AI. What we've seen, and also as an experience, that you quickly do things rapidly, proof of concept, you quickly do things. Then the incremental part to make this happen to production is quite difficult. That's where you probably need someone that put time and effort and experience to push this performance until the level we want to go to production. This is where I see that someone with experience can do the job. That's true. We can do our proof of concept on generative AI. That's the point. Okay, now I have to push to production. This is not working very well. I'm going to wait and iterate. Wow, this is still not working very well. What can I do? This is where you ask maybe for someone who's more experienced.
So related with this previous question about the coordination of the development team, but even in more generic way, to talk about data quality, ethical, a lot of aspects. In fact, thank you for the presentation, was very teachy. What area in the organization should lead all this coordination of these people, areas, and so on? What do you think?
Yeah. So, what kind of company are we talking about? What we're seeing that there is some, now it's so big that there is an area per se that it's taking care about this AI governance or trying to put in place this set of practices or set of framework so that you have that equity. The thing is, you don't, not always you have that part of the another team working on that. So it depends on the size of your company. But once you have in place this framework, then it has to, the ownership and the responsibility of it has to be translated to the team that they work on. But you have to get the framework and the tools to do that, and that's a little bit tricky how to start. So what we've seen, that's what we work in the company was when there was already that AI governance team in place, and there was building that set of policies and framework, and then ownership was translated to the one that created data. I don't know if I answered.
No, it's clear. Basically, I think that the key word that you said is AI governance, but at some point to build a framework, but at the end to know that you have to be the ownership, you have to be deployed in the areas, and they have to have the ownership somehow.
Yeah.
So I think it's probably a good alternative to consider a kind of community of practices or community of responsibilities around the AI. I mean, the same direction. So instead of to co-creating, a culture in the organization around the AI, it's a good strategy.
Can you speak louder? Because there is a noise just here.
Thinking in the possibility to structure a community of practice or a community of responsibilities around AI in the organization. Do you consider this a good approach? To spread the information
Yeah. What we say that for many products, some communication collaboration is key. So it's not about AI here, but it definitely applies to AI. So communicates the risk, the needed quality, and create that groups that foster that practices. So mixing data engineering, machine learning, and data scientists, and then the products also has to know what data they want to put in our system to be analyzed and in what quality. So they really are also in the center of this loop, not just about technical department. But yes.
The more we communicate, the better, because also the way it helps us to manage expectations. Because what happens now with all this hype is that certain departments they have high expectations, and then it's our task as well to kind of lower those expectations and be clear what can be done, what cannot be done. And I think, as you mentioned, just try to involve everybody would be much easier to manage the situation.
What is your perspective on the fact that there's a way the AI is here, generative AI is here, and we reduce the hallucination, but there's still hallucinations. So you're building a project and you're selling big project, but you're still on the risk of an hallucination in the wrong time, the wrong person, and having the level to say, verify your facts, because this might not be accurate, makes it, if I'm going to verify everything, I might not trust anything. So I suppose we're going to get to something at some point, but today, what I see is still that a lot of generative AI has that be careful. This might be completely inaccurate because we cannot.
Yeah.
So you're gonna sell a big project to a big company
Yeah.
with a little label to say this might not be accurate. So, what's your perspective on where we are and how to do with that?
So that's a completely tricky question. There is a lot of research on improving the validation or the factualness of the system. It's just not about putting the reference, but you have to when you create a system, you have to if you have a completion of LLM and you put the reference, there is a process that divide all the statements of the completion and enforce or look at if all the statements are supported by the reference. So there is a lot of research and practices that tries to remove that hallucinations. I think, yeah, there is. This is one of the ways one of the tricky way for generative AI, and there is a lot of research put into that. Okay, so that's good. We are into that selling big project, and we still have this warning. But yeah, we have to put that one place. We have to put that evaluation in place in order to still reduce that, and until we get into a good understanding of that practices has removed all of the possible hallucinations. We would be able to use maybe this warning, but yeah, we're not there. Actually,
These are the limitations of the algorithm. Right? All algorithms have limitations, and this is a clear one of Gen AI. Research has been conducted in order to improve it, but is there. So we need to be clear on the limitations as well. And there might be some domains which that can be acceptable, but in some other domains that's not acceptable. So just always bear in mind your use case and try to balance whether you can do that freely or you should, put more things than just a label.